So I'm watching this Anton Petrov video about accretion disk discoveries. I had to pause it because I had a thought. He's talking about how all accretion disks seem to have the pattern of the material in the disk spiraling and eventually falling inward. Now, with a black hole, the problem is one does not simply fall into a black hole. There are only certain angles and trajectories that can make it through gravitational waves, other things, magnetic fields, the tidal gravity, and everything else. That stuff that breaks up just stays in orbit in that center and becomes more and more compact as well. But wouldn't necessarily enter, even like the photon ring is a place where photons are trapped orbiting infinitely in a loop in a layer. So anything that happened to pass through a trajectory that goes, if it's a rotating black hole, which we've never really seen one that doesn't, there's going to be kind of a stretching of multiple types of event horizons so that they will overlap in some places and not overlap in others. And if material was to fall in through one of these event horizons, it's possible that that is what is then ejected out of the relativistic jets, which are kind of a magnetic field phenomenon, and as is the disk. There's a whole wild thing going on with the interaction of gravity and electromagnetism. But here's the thing that occurred to me. An object passing through the event horizon and coming back out on the other side is not going to do so at the same time. It's going to do so in the past or the future. So you would never see it come out on the other side if it was in the future. And if it was in the past, it would come out in the jet. And I say this because we look at these Fermi bubbles and these structures of some far past distant energetic event. But most galaxies we look at actually do have an active jet, which means ours probably does too. And it's possible that we can't see it because it is past tense only, due to moving slightly faster than the speed of light for just a moment, or relative to everything else faster. But therefore relatively being time traveled to the past. This means that the relativistic jets from supermassive black holes would be streams of reverse time coming from the poles or wherever the jets are aimed. And the fact that the jets don't even have to match up with the rotation of the rest of the system is a whole other thing. That's kind of that whole future versus past versus present, or maybe there's something quantum going on about, your likelihood of finding the jet location at any given time that you're looking at it, and that it might be at a different location some other time, just like the plasma globe having those tendrils, and some of them kind of dip and a new one forms. And it's not actually instantaneous. If you watched it in super, super slow-mo, you'd be able to see the one kind of... But sometimes it looks like they're like... So maybe that's the thing too. But importantly, consider the possibility that relativistic jets are moving faster than light, at least for a moment, which means that the entire jet and its motion is automatically past tense when it leaves that area. The universe is weird.